Good afternoon. Today we are going to learn inferential statistics. First of all, my name is Dr. Biplab SInhamahapatra. I am faculty of School of Applied Sciences and Humanities at Haldia. Before we start, Abraham D. Muivar, who invented e to the power I theta equals to cos theta plus sin theta, which we know as a complex number and trigonometric connection. He has first started the probability with the publication of the doctrine of chances. In 1733, he invented the normal distribution, which is the most important distribution in statistics. So, in this topics, which are we are going to learn, three topics we are going to cover. One is sampling and its distribution. Second, estimation of parameter, and third is testing of hypothesis. So let me start. This is the chapter name, sampling and its distribution. So sampling theory is a bridge between probability theory and inferential statistics. Inferential statistics means here we can draw a decision from the data we have collected. So first of all, what do we want to do in these inferential statistics? We have a population. So first of all, what is a population? Population is the collection of object or data which is under study. Size of population may be finite, may be infinite. Sometimes it's infinite in terms of it can be countable, but the time and money both are not allow us to count. That's why it can be a infinite population. Sample is a collection of population, and sampling is the process by which we are collecting the sample. There are two types of sample. One is called large sample, and another is called small sample. Usually, we believe that there are lots of theories about this. That if the n small n, which one is here, small n greater or equals to 30, then it called this is a large sample. Otherwise, it is called small sample. First, we try to learn the sampling process by random sampling. Random means everyone having a chances of being selected equally. Two types of random sampling we are actually going to discuss. One is called simple random sampling with replacement. Another is simple random sampling without replacement. So difference is here, with or without. With means usually you have collected that, you have to return to the box and then you will collect another sample. And without means usually once it is collected, it will not be returned to the box. So number of samples are differs a lot in these two cases. If it is SRSWR, SRSWR means simple random sampling with replacement. Then its formula is n to the power n, small n to the power capital N to the power small. Capital N is the number of size of the population, and small n is the sample size. So if you have only five, let you think only five is the size of a population, and we want to collect a sample of 2. Then it's number 5 square, 5 to the power 2. We call it face to the power number. Then 5 square means 25 you are getting. But if it is without replacement, then it is simple combination n capital N C small n, and in that case it is 5C to 10 only. So now you can understand that what is the difference between these two sampling procedure. If it is SRSWR, then the number of samples are huge, and if it is SRSWR without replacement, then the countable. It is very countable number of samples you will get. Now, two types of characteristic. One is for population, another is for sample. So population characteristics are called parameter, which we want to get, but for the large number of data, we are not getting to calculate that one. and statistics is the characteristic of the sample. So sample characteristic basically is called statistic. Now we have the sample, we have the statistic. Now we want to reach up to parameter. That is our job to do in inferential statistics. And in between, we have to apply lots of statistical measures, statistical technique. That a statistician is job. Now, first of all, sampling distribution of sample mean. This is what we are going to discuss. Another topic is sampling distribution of sample variance. These two are topics will be covered in this chapter, sampling and its distribution. And two, three things that we will discuss. Population mean is denoted by mu, population SD is sigma, and population proportion is by P. Whereas in statistics, in sample mean is x bar, sample SD is small x, and sample proportion is capital P. These are the differences. Now there are some theory how you can get the sample variance or sample SD from the population one. Look, if we calculate this one, then there are four variable variety. One is the sampling is SRSWR, without with replacement, and the population size is finite. It depends on two things. One is how you are collecting the sample, and second one is how the size of the population. So if it is finite population, okay, finite population means capital N is finite, and you are doing this sampling with SRSWR without replacement, then it is only sigma by root n into root over n minus n by n minus 1. This is the formula. Otherwise, it is sigma by root n. So 90% cases you will get sigma by root n. That is the case because it's called logically 75% cases, 4 cases, and it is covering 3 out of 4. Next, sampling distribution of sample variance. Look, two things we need to consider, that whether the problem is related to population mean or population variance. If it is population mean, then two distribution to consider. One is Z distribution, mean standard normal distribution, or it can be a T distribution, student T distribution. And if it is variance related problem, then we need to consider chi-square distribution. Variance is a positive quantity, that's why it comes only in the right hand side, that's why it is only positive side you will get. And in that case, chi-square distribution is only fit with variance related issues. Now, if I go for a problem, look, a normal population has a mean 0.1 and SD 2.1. So, and find the probability that the mean of a sample of size 900 will be negative. This is the question. So, question is to find the sample probability when the mean of the sample size 900 will be negative. And it's some related data given probability of mod z less equals to 1.43 equals to 0.847. Now, first of all, when you are solving a problem related to probability, it may be only a probability case or it may be a case of a statistical problem. Both ways you can find the probability. Now, difference is that when you are solving a problem related to only probability, then the formula for Z distribution, when standard normal distribution, Z equals to x minus mu by sigma. That is very simple. Z equals to x minus mu by sigma. Now, when it's come to a statistical problem, then this sigma will be different and x will be x bar. Then formula differs by z equals to x bar minus mu divided by sigma will be replaced by some variable. Which one? Which one we discussed previously? Sigma by root n or sigma by root n into root over n minus n by n minus 1. Now look at this problem. Is given normal population has a mean 0.1 when mu equals to 0.1 and SD means sigma equals to 2.1, and what is the size of the sample? Size of the sample n equals to 900. These things are given to you. Now let's look at this. Is there any word related to population size? It is mentioned in the question. Answer is no. When it is not mentioned, then we call this population size is infinite. Let me tell you why. If it is finite, then you have to tell how much it is. Otherwise, it does not have any meaning. If you are telling that it is too much, that does not have any meaning in statistics. So you have to tell it whether it is 1,000, whether it is 1 lakh, whether it is 10 crore, that you have to mention. Since it is not mentioned, we call it is infinite population. Next thing about the sampling procedure. I will discuss about two procedures, SRSWR or SRSWOR. Now, if it is with replacement, then it is natural. I mean, whenever we are collecting some sample from a population, naturally we don't want to return it. If you are returning, you are doing something extra. In that case, you have to mention. So both cases are not mentioned here. So it is as SRSWR, WOR type sampling procedure, and population size infinite. So the formula for uh, sigma for standard deviation is sigma by root now. Therefore, Z equals to you are getting x bar minus mu by sigma by root. Put all the values except the x bar. Now they are asking to find about the negative sample mean. Negative, when it will be negative? If it is less than 0, then it is negative. So we are going to find the probability of x bar less than 0. Now z equals to here 0, 0 means x bar equals to 0 here, and you are getting minus 1.50. So we are going to find the probability uh, in terms of standard normal distribution is probability of z less than minus 1.53. Now look at this. It is given you that mod z less equals to 1.43 equals to 0.847. So minus 1.43 to 0 is half of that area, and less than will be left side is 0.5 minus that 0.4235 and the real answer 0.0765. Another case is second one. Look at this. This is the mean weight of 500 ball bearing is 5.02 gram and HD 0.3. Find the probability that a random sample of 100 ball bearing would have the combined weight 510 gram. Now look at this. What is given here? The mean weight of 500 ball bearing. 500 ball bearing is the size of the population. So capital T equals to here 500. Mean equals to mu equals to 5.02 and sigma equals to 0.3. These are given to you. Now sample size is 100 and combined weight 510. Then one of them is weighted 510 by 100 means 5.10. That is the sample mean. Now put the look here. The sample size is finite and the sampling procedure is SRSW over. So formula will be different here. Sigma by root n into root n minus n by n minus 1. Put all the values, you are getting 2.96. Now look at this. 2.96 means you are finding greater than, when combined will be greater than 510. So x bar greater than 5.10 means you are getting probability of z greater than 2.96. So 0 to 2.96 is 0.4985. Then beyond 2.96 is 0.5 minus that one, 0.0015 answer. The same problem we can discuss, but these two are enough to learn the sampling distribution of sample mean. Only two cases we have discussed. Next one is a problem of standard deviation. Look, from a normal population of SD root over 20, sample of size 5 are drawn. So what you get? Population SD, sigma equals to root 20 and sample size small equals to 5. Prove that the probability that the sample variance is greater than 2.336 is 0.90. This is the proof. And find the mean and variance of the sampling distribution of sample variance where chi-square 0.90 semicolon 4 equals to 0.584. Let me discuss first of all what is given here. Chi-square is a positive variate, mean from 0 to infinity only. So it means that the probability of chi-square greater than 0.584 equals to 0.90 for 4 degrees of freedom. Now, what is degrees of freedom? Degrees of freedom is the number of variable, free variable we can get from an equation. For example, x plus y plus z equals to 3. So here number of equation equals to what? Number of variable equals to 3. So we can choose 3 minus 1 equals to 2 variable value freely, and 1 we will get from the equation. For x plus y equals to 2, you will get one equation and two variable. So 2 minus 1 means 1. That is the basically degrees of freedom. Now look at this. Chi-square formula is n square by sigma square. The probability of n square by sigma square greater than 0.584 equals to 0.90. Put the value of n and sigma square, you are getting probability of s square greater than 2.336 equals to 0.90. This is to prove it. Greater than 2.336 equals to 0.90, that is proved. Now, if you want to find the mean of sampling distribution of sample mean, then you are finding expectation of s square by 4. Why it is 4? 4 is the degree of freedom. Equals to 4 minus 1, which is 3. Therefore, expectation of s square equals to 12. And when it is variance, then variance of s square by 4 equals to 2 into n minus 1. 2 into n minus 1. For that reason, since for variance we have two equations, one for mean and one is for variance, mean expectation of s square. That's why it is 2 for first equation n minus 1, second equation n minus 1. So it is 2 into n minus 1. And variance, mean variance of ax plus b equals to a square variance of x. That's why it is variance of 1 by 4 square, and variance of a square equals to 6. So variance of a square equals to, you are getting 96. So that is up to 3 problems we have discussed, and we discussed about the population and sampling difference, and what is the sample mean and sample variance distribution in terms of sampling. Thank you.